Hey, BC Calculus, it's Mr. Canfield. We're going to continue our work in Chapter 17. We're going to look at something called a convergence test in this portion of 17. So we're going to run through a series of tests. The first test that you need to know is the nth term test. It is the most important test. And we informally discussed this last time. So when we looked at a sum, so I think we use a sub n, right? A sub n equals 1 to infinity. If, to figure out if it converges or diverges, the first thing we do is the nth term test. And what we ask is, hey, what's the limit as a sub n, shoot, I already screwed it up. What's the limit of a sub n as n goes to infinity? And this is just saying individual term, not partial sums. What's the limit of our individual terms? And so what the nth term test tells us is if this goes to infinity, I'm sorry. If this goes to 0, then we need to investigate. So if the terms are going to 0, we can investigate further. If the terms go to anything else, divergent. This is the nth term test. So if you want the more like wordy way, if the sequence a sub n does not converge to 0, the series diverges. If the sequence a sub n converges to 0, the series could converge. Another test is necessary. So, for example, n over 2n plus 1. All right, this is our first example. What are the terms of this approach as we go out to infinity? A half, right? These are approaching a half. What's a half plus 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 a half? You keep adding them up, you're eventually going to get to infinity. Because of that, this definitely diverges. And I like the alliteration there. So definitely diverges. And I like using definitely diverges because it's definitely diverges and it could converge. So since this is not going off to 0, it's going off to a half, it definitely diverges. If you want more of a discussion, Stu goes into it. It's great, it's cool, it's awesome. We're gonna keep going. So this is a nice little yeah. All right, so let's look at these. So what are the terms going off to? They're going off to infinity. It definitely diverges. This next one. What are the terms going off to? 0. It definitely maybe could converge. This could converge. And just secretly, just between you and me, this actually doesn't converge. But we don't know that yet. Sorry, is this ASMR enough? So just so you know, this one doesn't actually converge. But based on our nth term test so far, that we say, oh, this could converge. All right, let's see. Part C. (3n over n factorial). Okay, so 3n over n factorial, what's that going to do as we go out to infinity? Excuse me. So if, we're just thinking about the individual terms here, right? So in case you don't remember how this works or it's not clicking for you, if they're exponents, we can like compare them and do some stuff with that. But we're dealing with n and n factorial. N factorial just obliterates n as we go out to infinity. So this basically turns out to, the bottom gets infinitely larger than the top, and so this is going to go out to 0. So this is going to 0, so this could converge. And using some other tests that I know that this does converge, but we need to look into it and do more research to find that. All right, so that's kind of our at a glance situation. I'm gonna cut the video here and name it nth term test, and then we'll do telescoping series in the next video.